My name is Samuel Wild. I'm from the University of Nottingham. I'm a postdoc here. I'm going to be introducing SONAIR, which is the simulation to real operational benchmark for AI and robotics. This is a collaboration between the University of Nottingham and UCL. So part of the project is Dr. Tianyi Zeng, Dr. Yao Zhang, myself, and Ming Yu. So we approach the problem of simulation data and real data, and there being quite a large gap between the two. Traditionally, when we train robots, you need quite a lot of data to actually train these neural networks and deploy them, and you have to do that within a simulation or within a physics solver. And the traditional pipeline is on the top here, where you will simulate the robot moving inside of an environment. You'll train the neural network, and then you'll deploy it. And what our benchmark states is that actually, before this, we really should be moving the simulation data towards real data first, with a model that a user may propose. And then from that real data, you can then train your network and deploy it on the real robot. Currently, we see that these humanoid robots are performing walking and doing flips, but you can notice these small errors where it might trip over. This is from the simulation to real gap, where things like friction and sensor noise don't directly map to one another. So our benchmark proposes that we will collect simulation data perfectly and collect the real data from our robots here in Nottingham and at UCL, and users can access a portal, test their models, and try to close that gap. So just as a nice example, I choose two sensors here. So one being an IMU, which is an orientation sensor, and the other being an electromagnetic tracker, which is a position sensor. The idea is that we'd simulate the inputs. So perhaps we move the IMU between 0 and 45 degrees. We will then send that data to a UR robot. The UR robot is a highly precise, dexterous robotic arm. And we will send that data one-to-one, so that the robot arm will move in the same way as the simulated input. And we will collect both of those data. So that simulated input we'll collect, and also the recorded data from those sensors we'll collect. So to validate that the robot moves one-to-one to our simulated inputs, we use a ground truth tracker. This ground truth tracker may be a motion capture system, which has an accuracy of position of 0.1 mil, very accurate. And if the error between the simulated input and the UR robot is less than a threshold, so the noise floor of the trackers, we will accept it and store it in the benchmark, so that users can actually trust our data. This is just an example of moving the robot in sim, and then seeing the robot actually move in real life. So users will be able to access a portal and see the metrics on the data, and actually understand when they run their model, how well does it perform. They'll see the simulated output. Just a bit of an idea on the route. So we're going to start with foundation. So actually making the bridge between the simulation and the real robot, and actually sending the data one-to-one, and ensuring that the time stamping is done correctly, so that there's no difference in lag across the data. This is quite critical. Then we'll move on to the Sim2real validation, which will be this motion capture system validating that our simulated results are perfect and below a threshold. This will also include a calibration of the specific sensors, so that users can buy the same sensors we use and follow the same robust calibration procedures and deploy them on their own rigs. We will then do cross-site collaboration. So between Nottingham and UCL, we will have two robots with two FICON capture systems and tracking, so that we have two geolocations, and we enable generalization. And then we'll also perform industrial hardening, where we'll utilize our industrial partners like Rolls-Royce and Lloyd's Register. We'll demonstrate how to use the platform, show them how to access the data and how they can utilize the benchmark models for industrial deployment. And then we'll push to official release. Thank you very much.